Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. My name is Nur Shahida binti Shafi'i. I am from Department of Geoscience, Faculty of Earth Science, University Malaysia, Kelantan. So today I would like to present my paper entitled Potential of Rare Earth Elements in Gomusang Granites, Gomusang, Kelantan. So before we go further, I would like to introduce the definition of rare earth elements and also the usage of these elements. So basically, rare earth elements or REE are a set of 17 chemical elements in periodic table with atomic numbers starting from 57 lanthanum to 71 lutetium plus scandium and also yttrium. So scandium and yttrium are considered as rare earth elements since they tend to occur in the same ore deposit as lanthanide and display similar chemical properties. REE can be divided into two groups, which are lanthanum groups and terbium groups. Lanthanum groups, also called as light REE, consist of lanthanum, cerium, praseodymium, neodymium, promethium, and samarium, while the remaining REE are under heavy rare earth element or also called as a terbium groups. So basically, rare earth elements are all metals, and the group is often referred to as rare earth metals, and they also refer to as rare earth oxide because many of them are typically sold as oxide compounds. So in terms of usage, REE have been recognized as valuable because of their unusual chemical and physical properties. REE are mainly used in the production of permanent magnets, metal alloys, phosphorus, catalysts in chemical processes, ceramics and glasses, car batteries, and others which are critical in many green technologies. The increasing demand for rare earth element is related to continuous development of technology that the elements are used in modern equipment. Although rare earth elements are relatively abundant in earth crust, however, they are rarely concentrated into mineable ore deposits. REE are associated with alkaline igneous rocks and carbonatites, as well as in sedimentary rocks. However, there is a significant value of REE deposits in association with granitic rocks and their related igneous bodies. Granitoid and some extrusive volcanic rocks are widely exposed in Malaysia, as shown in this map, including Kelantan territories. About 40% of granitoids form on the land surface and as a bedrock of main mountain ranges. The geology of Kelantan Central Zone is composed of sediments and metasedimentary rocks that are bordered by main range granites to the west and boundary range granite to the east. The study area is predominated by Middle Permian to Late Triassic Gomusang Formation. The Gomusang Formation is very well exposed in northern part of the Gomusang. This formation consists of pre-Mesozoic metasediments such as shallow marine, argillaceous facies made up phyllite, slate, and hornfels. In Gomusang, there are two different granites are exposed. There are grey granites with slightly phosphoryric and the pink granites. For methods, involve geological mapping and geochemical analysis. The geochemical analysis was carried out to describe and analyze the elements contained in granitoids. Elements in the rock are determined to the intermediate level of accuracy. Inductive coupled plasma mass spectrometry (ICP-MS) is an analytical technique that allows more sensitive detection in determining a wide range of extremely low detection limit of atomic elements below 1 part per trillion. This technique is highly recommended for trace elemental analysis as it offers a high speed of analysis, accurate detection limit, and isotopic sensitivity potential. So for result and finding, rare earth element was obtained from ICP-MS analysis for 10 samples of granitoid rocks. Light REE was obtained at SAP. Promethium, which is the rarest, only occur in trace quantities in natural material as it has no long-lived or stable isotope. The total REE elements in 10 granite sample in Gua Musang is ranging from 88 ppm to 575 ppm, as the previous reported finding indicates that the total REE in the Peninsular Malaysian granite is ranging from 85 to 415 ppm only. So our data shows that out of 10 samples, 7 samples have value of more than 100 ppm, with sample 002 appear to be the highest value of total REE with an amount of 574.3858 ppm, followed by sample 006 with a value of 311.6130 ppm. This figure shows the light REE and heavy REE distribution in 10 granitoid samples measured in ppm unit. The total light REE are generally high value with a range of 55 ppm to 450 ppm, while the total heavy REE are generally low with a value ranging from 2 ppm to 128 ppm. As expected, light REE are more abundant than heavy REE, as the heavy REE are known to be less common and more valuable compared to light REE. So when we focus on distribution of light REE, it shows that cerium, neodymium, and lanthanum appears to be the most prominent element within all 10 samples, while the distribution of praseodymium and samarium are generally low. Theoretically, according to Kester and Hedrick, the abundance of REE may relate to two main factors. The first is REE is even atomic numbers have an even atomic numbers greater abundance than their odd number neighbors by Odo-Hakim effect. And secondly, the lighter REE are more incompatible because they have larger ionic radii and consequently more strongly concentrated in continental crust than REE with larger atomic number. The chemically similar nature of REE means they can substitute for one another in crystal structure. This results in occurrence of multiple REE with a single mineral and a broad distribution of earth crust. Nevertheless, this is not the case for some of the sample. For example, for the distribution, the concentration of neodymium and lanthanum show that neodymium has higher concentration compared to lanthanum. So this observation may be due to the atomic weight of neodymium is higher than lanthanum. However, this is also possible that lanthanum can be higher than neodymium due to the atomic radii of lanthanum is bigger than neodymium, makes lanthanum is more easily to aggregate with the rocks. For heavy REE, the most abundant element within all samples are yttrium and gadolinium, ranging from 1 ppm to 92 ppm for yttrium and 0.04 ppm to 30 ppm for gadolinium. Other samples, however, show the similar REE distribution and are considerably below than 1 ppm. So based on this figure, thulium and lutetium show the lowest distribution reading as they are two least abundant of REE elements. For the conclusion, as expected, light REE are more abundant than heavy REE, as the heavy REE are known to be less common and more valuable compared to light REE. The abundance of light REE compared to total REE in the majority of samples are up to 90%. The total REE in granite sample of Gua Musang shows highest concentration in sample 002 followed by 006, 007 and others. with the highest concentration is 574.3858 ppm, while the lowest is 79.7913 ppm. Reported range of total REE indicates that the total REE in the Peninsular Malaysia granite is ranging from 85 to 414 ppm and ranging from 85 to 327 for East Coast granite. Thus, the sample from 002 in our paper with a total RE of 574.3858 ppm might be considered as a good potential of RE since the abundance of RE is exceeded the reported range. I have now come to the end of my presentation. I would like to take this opportunity to University Malaysia Kelantan for funding these research activities and providing the equipments and facilities for this project. We also would like to thank the staff and students of Department of Geoscience for their contribution and continued support during these works. So finally, thank you all for being here today and taking the time to listen to my paper presentation, and I wish you all a blessed day. Thank you.